Hello everyone and welcome to our video. In this video, my team will be discussing about the teaching issue in assessment of measurement geometry, statistic and probability. This is our task for continuous assessment of MTAS 3273, teaching and assessment of measurement geometry, statistic and probability. Enjoy! So this is our group member, me, Ryan, Onel Anathep. The middle one is my friend Tan Kendall, and the left one is Tuan Muhammad Arif bin Tuan Suzaman. Now, before we move on to our introduction, I would like to explain to us what a mathematics misconception really is. Now, a misconception is an incorrect or incomplete understanding of a mathematics concept. Students may develop this misconception in multiple different ways. For example, misconception first usually occurs when the student misinterpret their previous knowledge into the new learning. For example, they bring the calculation method from previous topic into the new topic, which are actually wrong. So next, misconception also occurs when the student apply incorrect procedure repeatedly. Now, I want to emphasize repeatedly because when a procedure is applied repeatedly, this is showing that the students are really not understanding the procedure and the purpose of the procedure. Now, the third one is most problematic one, when the student form their own explanation from an unfamiliar concept. I can give an example like when they use a not suitable explanation from another topic directly into the topic that they are learning right now. They think that every explanation and calculation is same for every topic. Therefore, this can show us that the student is really not understand what the explanation is about. So basically, misconception are not simply mistake. There must be a stable, inconsistent idea that the student believe are correct about the solution. That it will be considered a misconception. Now, for our presentation, our group has chosen a common misconception that have been occurring in Year 4 topic of measurement. Now, measurement is an important topic in primary school mathematics because student need to understand both mathematical operation of plus, minus, times and divide, and the unit conversion that is occurring has been occurring a couple of lot of time in this measurement topic when solving problem involving liquid, especially liquid volume. Now, however, many pupils struggle when first of all is converting the unit correctly because they doesn't really understand what is the unit. For example, like liters and milliliters is actually about what the unit is meaning and what is the conversion rate. Now, beside that, the pupils also has many problem of understanding the place value during the multiplication, where they cannot put the place value correctly, so they will write the answer basically wrong lah. Now, this is the research article that we are referring to do this presentation. So in short, this research indicate that measurement occurs such as measurement concepts such as volume and capacity are often misunderstood by primary school students especially when they involve multiple unit and the unit conversion. Therefore, it is important to identify student misconception and develop the appropriate teaching strategy. So, in short, I will summarize this article for us. This article is talking about the student misconception, especially in measurement topic, where the student cannot understand the place value in the calculation step, and they cannot change the unit of the value in volumes. Now, in this article also has suggested a few strategies to overcome and solve this problem. So next, I will be passing on to our friends Tuan Arif and Tan to show the evidence of the misconception and explain how to solve each of the misconception.
So, from the research that we have done, now we can identify what kind of mistakes that the student have made. In here, we have two misconceptions. The first one is the students misunderstood the place value in multiplication. So, from the picture here, we can see that the student makes some mistake during the multiplication with the number 250 times 50. So, in the next slide, I am going to explain the place value displacement error that the student have made. So, in the provided work, the student is attempting to multiply the 7 liter and 250 milliliter by 15, while the first row of the multiplication is actually correct. The process falls apart immediately after. So, there are two factors that the student have made during the calculation. The first one is the missing zero. When moving to the 10th place, the 1 in 15, the student treats as is a 1 rather than a 10. In a standard multiplication algorithm, they should have written 70 liters and 2050 milliliters. Instead, they simply rewrote the original value, which is 7 liter and 250 milliliters, as if they were multiplying by 1. The next factor is regrouping paradox. After summing the rows to get the 42 liters and 1500 milliliters, the students realized that the 1500 milliliters is too much. However, instead of converting, which is subtracting 1000 milliliter to add 1 liter, they add another 1 liter and 500 milliliters to the total. This resulted in an even larger and more incorrect volume, which is 43 liters and 2000 milliliters. So, in this slide, I am going to explain why did the students make this error. There are two explanations. The first one is island thinking or unit isolation, where the student is treating the liter column and the milliliter column as two separate islands. Because they are focused on the vertical alignment of the numbers, they forget that the milliliter side has a cap of 1000. This is a common transformation error identified in the Malaysian education research, where the students perform the math but fail to transform the unit correctly. The second one is misunderstanding the conversion mechanic. The bottom of the image earlier shows the most telling mistakes, which is adding instead of replacing. The students know the rules, which is 1000 milliliter is equals to 1 liter, but they apply it as an addition operation rather than an exchange. They likely thought, I have 1500, so I will add the 1 and the 500 I found to the total, which instead double the error that they made in the calculation. So, how can the teachers solve the problem of the students? In this slide, I'm going to show a flip and found method that the teacher can use. Here's a step-by-step how the teachers can do it. So, for the step 1, the teachers can set up the grid. The teachers has students write the problem into a grid that separated the liters and milliliters into their own columns. In here, I used the different question, which is 5 liters and 300 milliliters times 24. So for the second step, they will focus on the ones or sa in Malay. The flip and found aids the place over the grid, so a pink flap cover the tens digit, which is the 2. Then the student will multiply the milliliters and liters by the ones digit, which is the 4. So here the student can see very clearly which one they need to multiply first, which is the ones digit instead of the tens digit. So for the third step, which is reveal the tens or puluh in Malay, the students flip the pink card to the right, which reveals a zero placeholder. This forced the student to realize that they are now multiplying by 20, not just 2. So the students then complete the multiplication for the 10th section. So from here, the students will instinctively multiply the 2 and multiply the 2 in the tens place, not the ones place. And step 4, regrouping or conversion. Because of the milliliter result are now visually organized in the grid, the students can clearly see if the value exceeded 1000 milliliter. For example, if the result is 7200 milliliter, the student can see that the 7000 milliliter must be moved across the unit boundary and become the 7 liter. So the final answer for the question will be the student adds the total in each column to find the final volume. So the final answer for it will be 127 liter and 200 milliliter. Why does this? Why does the flip and found method works for the year 4 students? This is because the research that we have found shows that this method is particularly effective for the students with visual and kinesthetic learning styles. By physically flipping a card, the student engage with the concept of place value through movement, making the abstract placeholder 0 a concrete physical object. In the study, all five all five year 4 participants were able to master the multiplication and unit conversion after using this method.
So for the second misconception, that is the misconception students cannot manage unit conversion between millimeters and liters. Here is one of the examples that we find on the internet thesis. So why students have difficulties or misconception towards multiplication involving volume or liquid, especially in liters and because even though students are able to multiply the 7 liters and millimeters with the times 15, but students fail to understand that converting 1000 millimeters must be converted into 1 liter. So as a result, the people from based on the photo over here convert write the final answer as 43 liters and 2000 millimeters, but that is wrong. Why students have this type of misconceptions? So it's because students do not fully understand the relationship between liters and millimeters. So, therefore, people also seems to think that liters and millimeters can be calculated separately without regrouping. So, millimeters are greater than 1000 can be made in the final answer, but no conversion is needed after multiplication. Thus, this shows weakness in the student's ability in the unit conversion, regrouping process, and place value understanding in measurements. So, there are many teaching strategies that can help students to understand the misconception between liters and millimeters. So, how do we as a teacher use those strategies to address the misconceptions the students are doing right now? So we can use the CPA, the concrete, pictorial, and abstract method on the students. For example, for C, concrete. The teacher can use concrete materials like measuring water, 1 liter water, color water, and container mark in liters and millimeters. So, with using the concrete material, can help student to visualize it and touch it and see it, so that the student can compare that 1000 liters is equals to 1 liters. So the second is visual representation, or is it the pictorial? So examples of the visual as representative that the teacher can use is the unit conversion chart, place value table for liters and milliliters, and step-by-step work example. Thus, students after seeing the pictorial diagram or unit conversion chart and many others can help them to visualize and then understanding the regrouping clearly. So last and but not least is abstract. That is guided practice. Give example. 3 liters 500 millimeters times 14, or 4 liters 750 millimeters times 9, and 2 liters and 600 millimeters times 17. So with this excessive and keep on doing our questions and latihan, this can help strengthen their skills in converting excess millimeters to liters, and thus students will understood and won't just memorize but will understand the millimeters and liters concepts. How teachers can solve the problem or the misconception the students are doing right now. So I think the teacher should focus on strengthening the pupils' understanding of the relationship between liters and millimeters. So, for example, teacher can explain step by steps of the process of the multiplication based on the photo given. So from here you can do like 7 liters times 250 millimeters times 5. Do the step by step. Like 7 liters times 5 equals to 35 liters. 250 liters times 5 equals to 1250 liters. So as we know that 1000 liters is equals to 1 liter. So 1250 liters, if we convert, it will become to 1 liter and 250 millimeter. So 35 liters plus 1 liter and 205 millimeters is equals to 36 liters and 255 millimeters. So from here, the teacher should emphasize whether the millimeter exists 1000, they must be converted into liters. So there are many teaching strategies that can help students to understand the misconception between liters and millimeters. So how do we as a teacher use those strategies to address the misconceptions the students are doing right now? So we can use the CPA, the concrete, pictorial, and abstract method on the students. For example, for C, concrete. The teacher can use concrete materials like measuring water, 1 liter water, color water, and container mark in liters and millimeters. So with using the concrete material, can help students to visualize it and touch it and see it, so that the student can compare that 1000 liters is equals to 1 liters. So the second is visual representation, or is it the pictorial? So examples of the visual as representative that the teacher can use is the unit conversion chart, place value table for liters and milliliters, and step-by-step work example. Thus, students after seeing the pictorial diagram or unit conversion chart and many others can help them to visualize and then understanding the regrouping clearly. So last and but not least is abstract. That is guided practice. Give example. 3 liters 500 millimeters times 14, or 4 liters 750 millimeters times 9, and 2 liters and 600 millimeters times 17. So with this excessive and keep on doing our questions and latihan, this can help strengthen their skills in converting excess millimeters to liters, and thus students will understood and won't just memorize but will understand the millimeters and liters concepts. So what are the teacher's role in remediation? So the teacher play an important role in helping pupils overcome this misconception. So firstly, the teacher should reach or we teach the basic concept that 1 liter is equals to 1000 millimeters. So this concept must be strong before the pupils can solve multiplication question correctly. Second, the teacher should model the correct steps in a clear and organized way so the pupil will all can be able to see not only the correct answers but also the thinking process behind the conversion. So third is the teacher should ask guiding question to encourage thinking. For instance, the teacher can ask how many millimeters are there in 1 liter or what should we do when the millimeter are more than 1000. So those questions can help the pupils to reflect on their own understanding. And finally, the teacher should provide practice from simple to more challenging questions and continuously check pupil understanding through discussion, questioning, and correction.
Alright, before we move on to our conclusion, I would like to emphasize the importance of identifying misconception in our student. So here I have listed 4 of the most common important. So the first one is to understand the student thinking. Okay, so when the teacher can understand, they can see how the student interpret mathematical concept and where is the misunderstanding actually occur. So next, all of this identification process is to help us improve our teaching strategy. By identifying misconception, the teacher can design instructional approach that is directly addressing each student unique misunderstandings, help the student to improve in their difficulties. Okay, the third one is to support the conceptual understanding. Okay, now correcting misconception can help the student build a stronger foundation for future mathematics learning. As we know, mathematics learning is something that we start from below, the basic, and then we start to explore and apply the basic to every single concept that we are going to learn next. Now, the fourth and final one is to prevent long-term effect in their learning. If these misconceptions are not addressed early, they may proceed and become an effect on the student performance in more addictive topic like I have explained just now. Okay, from what my friend Tan and Arif has shown us, the example of student misconception in this measurement topic, I'm gonna conclude the whole presentation. So first of all, misconception, I remind back, misconception is a representation of the student incorrect conceptual understanding in a certain subject. For example, right now is mathematics. Then this misconception commonly occur in measurement topic because it's due to the combination of operation where the student need to produce plus and minus operation and times and divide operation in the same time. And in measurement topic also, there are unit relationship involved here where the student need to understand the difference between each unit, for example like liter and milliliter, before they even started to solve the question. And third is we should understand the student misconception. This is essential because this step will help us to improve our teaching practices. For example, if we find out that our first method of teaching will produce a student with misconception, therefore we can improvise or create another teaching method which will conclude in producing a new student without misconception in the topic. Okay, so finally, it is our duty as a teacher. We should analyze each and every one of our students to help them so that they can and support them to think in their meaningful learning of the future.